Well, good evening, good morning, good afternoon, good ever what time of day it happens to be that you are listening to the Tattoo Teacher podcast. On today's episode, I have Andrew Nicholls. Now, we first met as I was a teacher and he was a parent of one of the students I was teaching. And then it happened across in conversation that we were both design and technology teachers. And we're both working in Queensland and neither of us are from here originally. So we had a bit of a joint connection there. So Andrew is, like I said, a design and technology teacher. He's head of department at a local government school. He is a PhD candidate. He's he's a workplace health and safety consultant, and a whole bunch of other things that he finds time to do. So Andrew, welcome to the show.
Thanks, Phil.
I appreciate you taking your time out to do this on what is term 4.
Yes.
A busy time. So, yeah, I covered all that sort of stuff. You're doing a lot. You've done a lot. But why education?
Gee, that'll take me back. Well, I originally started out as an industrial designer, went through the whole figuring out what I wanted to do and took a break and ended up in industrial design. And this was turn of the century, 99, 2001. And at that stage, of course, we had the economic problems of the time. There wasn't much work around for industrial designers. They sort of churned out about 150 of us a year, but they just weren't the jobs. So I ended up I was originally working in photographics as I was completing my degree. And then I went from that to, what did I do? Point of sale. So I first started in working for a graphic designer. In fact, it was a screen printer, and he had me working out the graphics to apply to three-dimensional cardboard. So that was really interesting job to get into. You suddenly found out that you needed to know a lot more about geometry than what you realised, because one wrong angle on that cardboard. So this is you ever walk into Coles or Woolies or any of the department stores and they've got the big fold-up Mars bar containers, or the big things at the end of gondolas or shopping roads, whatever you want to call them. And yeah, he'd walk in and go, right, this week we've got Mars, next week we've got Disney, next week we've got, some book publisher. I need you to make this, that, or that, and it has to have a free holding stand. So all of a sudden I got used to, folding tabs and bases, and if there was ever so much of a blemish on the cardboard surface or the graphics, it'd be nuts, start again, you got one of the angles wrong. So I did that for about 6 months. It was wax and wane. 1 minute you'd be flat out and you'd be having to work until 6 or 8 o'clock at night getting a job done, and then the next minute we'd have absolutely nothing. So you'd be sitting there twiddling your thumbs and just mucking around on Illustrator or playing with a CAD program, a case maker I think it was called, one dedicated for the paper industry. And at that stage I went, I'm not getting anything out of this, not enough mental stimulation for me. Started working for a kitchen company, pretty major one that went Australia-wide and made kitchens for all the big housing companies. And that was pretty much a CAD jockey role. It was transferring plans, architectural plans, into an architectural or a cabinet making program, and it was just transferred. From 9 o'clock in the morning till 3 o'clock in the afternoon, you did pretty much the same thing. And at that stage, I sort of thought, I've got to do something more. There's more to industrial design than just transferring plans. I'd also met my wife at that stage, and we were looking at buying our first home. So of course, when we went to the bank, and they said, "You're all right, Kimberly, that's my wife's name. You're a teacher. You've got a steady job. That's great. Andrew, you're a designer. You keep changing jobs every 6 to 12 months. You're not stable enough. Go and do something for real." I was like, "Oh God, okay." And my wife then suggested to me, "Why don't you go back and do a dip ed and become a teacher?" And I thought, okay, steady job. I don't mind teaching people. She said, "You're really good at instructing people and you've got the patience to do it. Have a think about it." And I was really lucky because at that stage, the University of Melbourne, I think we were the first or second cohort of their dip ed, which no longer exists, but it was the first or second year that they had actually offered technology as a teaching method, which we now know that that's pretty rare. There's a lot of universities that just don't offer technology as teaching anymore.
No, most of them canned their departments, which is a real shame.
Yeah, we've only got New South Wales, I think, has got one university offering it. I think there might be one or two up here. We've just picked up a teacher candidate at my school who's a trade to teach, which is brilliant. Love it. It's great. But I wish there'd be more universities just to pick up technology teachers to help us out.
Absolutely, and it's almost well on that point, almost worthwhile bringing trade to teachers, bringing back that dip ed, because there's so many guys out there who are just so upskilled and have so much knowledge, so much practical knowledge of CAD, of assembly, of workplace safety. They could just roll into a classroom, but the thought of having to go through a year or two of university and basically not get paid,
Yes,
it's pretty hard.
well, it's that rollover, isn't it? It's 12 months, which what the dip ed used to be was perfect. And in reality, it's probably closer to about 8 to 9 months. Whereas the new Masters of Teaching unit is 18. So it's although we're trying to elevate the level of teacher being graduated out of universities, it's just that little bit more stretch for people to not have that full-time job to be paying mortgages or doing anything else that they need to be able to afford to live. And particularly when you turn around to graduate or new teachers and say, well, actually you're going to come in and you're going to start your base salary for teacher. It's hang on, that's stepping down from what I'm earning in the industry. So that's not a huge incentive for them either.
No, exactly, and especially guys and girls moving from their trade into teaching. Like some of them are making good 6-figure salaries,
Yes.
and then to go down to lose upwards of $50,000 to $60,000, probably at
Yep.
a minimum. Some of them,
Yep. And extended work hours. Let's face it, we don't work 9 till 3. There's that extended hours where you've got your correction and your planning and everything else that occurs, and then of course your workshop maintenance and or your compliance that goes with the job.
Absolutely. So it was almost it's one of those things where I've spoken to a number of my other guests and myself as well. It's like we're accidental teachers.
Yes.
We were doing something else and we thought, I can't see myself doing that forever. And then someone, for you, it was your wife. For me, I was talking to a whole bunch of people, and then my brother-in-law goes, hey, there's this new course at what's it called, Western Sydney University now. It was the University of Western Sydney back then. Mine a technology degree, so I did industrial design. I focused in industrial design, and then I did a teaching one, and then all of a sudden I'm a teacher, and now it's 2025, and I've been doing it for 23 years.
Yes.
I've been in the classroom for 23 years, and it's just like, what happened? And how did I didn't know what I wanted to do, and I was doing well in my trade and my chosen career at that time, and then here we are.
Yes.
You guys have been in the classroom for quite a while now.
Yeah. I'm surprised now that I turn around and we've got graduate teachers coming in or younger teachers coming in. And you'll start doing things, and it's just, that automatic mode is just kicked in now, and it's, well, yes, okay, yeah, you've got to move around the classroom, you've got to do this, and this has to happen in your planning. And when you're standing here and you're watching, the young person standing in front of you using a tool for the first time, but you've still got to have eyes over the back of the classroom to see what's happening and who's going into where or who's about to do something. You go, oh, hang on, we're just going to stop here. I'll be back in just a second. You go and help that other student and then come back again. The newer teachers sort of go, well, how do you have eyes here and ears over there? And are quite mystified by that idea that you're looking here, but you're also looking around the room as it's happening at the same time. It's funny.
Yeah, you're giving that explicit teaching of a piece of equipment, machinery, whatever it might be, and then all of a sudden you I've got I can hardly hear what's going on generally, but there's when I'm in that workshop environment, it's like it's my superpower. I can hear this conversation over here, and I know those boys are laughing about something, so I need to pay attention to that. Who's about to start crying, and then yeah, they look at you like, how do you
do that? How'd you hear that over the sander? Oh, you just know. You just third sense.
Yeah, there's sounds that shouldn't exist in the room.
That's right.
So you've done all this. You got your job. You started teaching. So obviously early 2000s.
Yep.
Now we're now in 2025, almost out of 2025. You've done a master's degree. You're raising a family. You're a head of department. You're now studying your PhD.
Yep.
You started a consultancy business.
Yep.
With the rigors of teaching, how do you fit all that in, or why do you fit all that in?
Glutton for punishment. I don't know. I found that it's been circumstantial, really, and it's not something that's constantly there. So, for example, the consultancy really came out of an opportunity which came from my Masters of Ed. So, I was actually studying my Masters in bulkhouse safety, and the Masters unit, because I did it online in the background from about 2010, 12, somewhere around there. And so I'd been doing that for about 6 years part-time. So it's really only one unit a semester, so 2 units a year is really all I was bad at doing. But that started off as a graduate certificate and then became a graduate diploma, and then that led into the Masters. So just as I was getting to the end of the graduate diploma of bulkhouse safety, I sort of put it to rest and just went, okay, I am sort of doing all these other things. I'm just going to put that to bed for the moment. And I really wanted to push my pedagogical practices. So it was more about trying to become the educational leader. At that stage, I got my first leading teacher job in Victoria as a head of department, or what is the equivalent of a head of department. And at that sort of stage, the leading teacher roles within Victoria were probably just maturing. They'd only sort of been in since 2005 at that sort of level for the teacher progression point. And there weren't too many leading teachers for technologies or curriculum areas. So in other sort of operational areas of the school, or mainly focused on literacy, numeracy, and your bread and butter sort of things within schools. So I went off to the University of Melbourne and then picked up a master's degree. And in that process, I was again fortunate that there was what was the marketing at the moment at that point? I think it was called Collision. So they were trying to fuse together different faculties within the university to try and see if they could leverage different effects, I suppose. So they actually paired together education with architecture. And of course, this was just after the BER, so the Building Education Revolution through the Rudd government. And they were starting to focus on how do we rebuild and reshape educational spaces. We'd been through the 70s, we'd done the whole open plan thing, then we put the boxes back in and bells and cells, and then all of a sudden during the noughties, we went back to the open plan because it was, we could do it from an engineering point of view, and it made more economic sense, of course, to make these big open spaces and then put a couple of things in between. Yes, because it was what's sold as new again. And of course, it was cheaper. Like, we can build these big monolith sort of buildings and put a couple of walls or some divisional things in there, and all of a sudden we've got 4 classrooms, and of course teachers can now team teach, and it's a great environment. So we looked at that, and I ended up writing a paper with a vet specialist. So They were quite keen to work in the space of technologies. And then we had 2 architects, and we sort of had to sort of do the meet and greet and the whole big circle thing of, I'm thinking about this and I'm thinking about that. Wouldn't it be great if we could look at this? The 4 of us sort of came together, and we all agreed that, hey, it'd be really great. The architects were really keen. And of course, when I sort of said to them, well, look, no one has really looked at the design of design technology facilities in 30, 40, 50, if not 60 years. And they all went, that's different. Let's look at that project. So we ended up writing a paper, and the task was at that stage we had to get a footprint of a school and then reimagine what that space could look like. And we could tear walls down, we could put walls up, but the outer footprint was fixed. And at the time I was working in the sort of northern region of Melbourne, so the outer northern region of Melbourne, and the school was built in about the 70s. So it had a hub in the centre of the school in the junior area, and it actually had individual classrooms. So one was a dedicated textiles, used to be an IT but got repurposed as a general purpose classroom, and then a metalwork, a divisional machine shop, and then a woodwork shop. So we said, okay, let's look at, the iteration of the Australian curriculum or the Victorian curriculum, and then how do we relay that curriculum and redefine that space? And that was a really interesting process to go through. And what I found out of that, of course, was that of the Australian curriculum, even if we look at it individually, state by state by state, has moved on and progressed and has advanced. And of course, our understanding of how the young mind works and what we need to do psychologically with them has changed. And our values in terms of how early we teach trade skills has changed. And of course, our idea of how long kids should stay in school has changed. So when we looked at it, we said, well, okay, we now have this design philosophy coming through. We want that to be able to be shown in the classroom, but the way in which we design schools is very much old school. It's wood, metal, plastics, textiles, IT, and never any of them should meet. So we said, okay, well, what would this space look like if they could? And we ended up designing a really, it was a complex task because you've got to have that open design space and it's got to be influential, and it has to, that whole space has to become a third teacher. You want to have your posters up, you want to have your signboards up, you want to be able to do your big graphics on the wall, you want to be able to have whiteboards where kids can walk up and draw and work ideas. You want to have a CAD lab that's close by. You need transparency between all of the walls and each of the workshops. I think at the time, at the time I'd actually come from a school that was a BER model, so an open plan. And it was a modular footprint that used to be a primary school. They've picked it up, dumped it in the middle of this brand new school and said, oh, we're going to call this technology. And then they left 3 rooms open to each other, and they put in a tiny little machine room. So by the time you put a table saw in there and a thicknesser, you didn't have any room to put anything through. So you had to cut everything down to 2 meters because that's all the room that you had to actually feed through the machine.
Yeah, and I guess the whole time you were studying occupational safety. So I guess looking at this task as well, you that side of your brain's going, hold on, there's all these safety issues that you are trying to compact all of this into a space that, one's not designed for it, and 2, as good as architects are at designing schools and they do some amazing things, they don't understand students anymore.
Well, even that was a more complex process, as I was to find out. So we went through all this project and we thought we solved it really well. We had linked, is probably the better way of saying it, we had linked material-based workshops. They have to be. But you don't want to segregate them across. The northern part of the school is going to have woodwork while the south side of the school is going to have metalwork. They've got to be closer. So we really want kids to be able to walk in and go, okay, I'm designing a chair or a light or whatever product that has to solve a human need. Sometimes not a human need. But we've structured it in a way that we could actually, and of course we were, blue sky thinking, we could actually have a teacher positioned in each of the workshops that becomes the master. And the kids could walk in and go, hey, miss, sir, I'm doing this out of timber. Could you help me? And then it's, okay, yeah, come over to the timber wall. We can have a look at what's on our storage shelves and we can pick different timbers and you can do samples of those and then you can do your experimentation and exploration. And then you can come back in and go, yeah, I want 3 meters of that and that's going to do this for me. Likewise, they could then walk into the metalwork room and go, I've got no idea about aluminium or galvanized steel. Can you help me out? Yeah, sure, no worries. Here's a bit of this, here's a bit of that. Cut it, bend it, shape it, file it, whatever. So that they progressively work through the different areas to help their project, and then they document that back in the clean room. So after all that project was said and done, the lead lecturers in that process was actually a practicing architect. I finished that particular course. We submitted the assignment, we got our marks, and we were all happy. We were progressing towards the end of the masters. And I then got a random phone call one day to say, hi Andrew, it's such and such. I work for this particular architectural company in Melbourne. We're doing a design layout for a new growth area in Victoria. We have to design a design and technology space. We'd be really keen for you to come in and speak to the team because we're looking at it, scratching our heads, and we don't quite know if we've got it right. We know that you're an expert in this area, well, so-called.
You do something once, and then, especially in our area, all of a sudden you're an expert. And you just go,
yeah.
I just got
you know
through.
what you're doing, or we think you know what you're doing. Okay, cool, no worries. So I went into Melbourne, and they said, look, this is a paid job. I did my whole, conflict of interest thing and filled out all the paperwork, so I didn't get in trouble with the department. And I went in, and they said, well, here's our plans. You tell us. So of course I pulled out the red pen and just went to town. And they've gone, oh wow, we don't even think about that. Like, whoa, hang on, what? Do you use chemicals in designer technologies? Where's your allowance for the flammable liquids cupboard? Where's the toxics cupboard? Where's your through line for material coming in off the delivery bay? And then, hang on, we deal in 6 metre lengths of timber. Like, we don't pay a timber yard $2 a cut to cut it down to 2 metres for us. We bring it in and then cut it. Where's the allowance to actually run a 6 metre length piece of timber through a docking saw? Wasn't there. So we educated them on all of that, and they made improvements. And then, about 6 months after that, there was the next iteration of schools being built. So again, they gave me the call, and then they said, okay, well, actually, we want you to do this on a commercial basis, not just, an ex-student of ours coming in and talking to us. And that's really where the consultancy then came in. And at the time, even prior to that, while I was doing the health and safety course, I was working very closely with Data. So I have a very strong relationship with Data Victoria, from being obviously a long-term member and presenter at probably about 10, 15 data conferences. I ended up presenting at Data and started talking to health and safety and how people can do it from a manageable point of view, and then work with their schools to negotiate things that teachers often have troubles with. So anything from appropriate footwear through to chemical management and risk management, and doing the argy-bargy about, well, we've got X square meterage, and I've got 14 burly 16-year-olds working in that want to produce objects that are 2 meters, anything from a tiny little set of bookends all the way through to a 2 meter coffee table. Hang on, this sort of stuff needs to be risk assessed, and you need to be able to have the arguments, and you need to be able to walk in there with the act and go, says here, this is what we need to do.
Exactly. So, and like, even to the point where, and I've had similar conversations with the powers that be, is, here's your room, just put all your stuff in it. And I say, well, yeah, we're going to buy you 6 workbenches. What? No, only 4 can fit in. Yeah. Why? Well, because you've got to allow this much workspace around it. Oh, we're going to give you all your machinery. Well, I can only have this machine next to this one because I've got to let you've got the lengths of timber coming, all that sort of stuff. Oh, yep. And for anyone who's listening, who's from overseas, Data is Designer Technology Teachers Association. That's what we have in Australia, and an excellent organisation who do great things for our design technology teachers. But yeah, there's all those things that we, I guess, just know about. That it's not that we take it for granted. It's just that we know the workplace health and safety environments, and both yourself and myself, coming from industry, also have a greater understanding of how it actually works and the consequences of poor workspaces, poor work handling, poor choice of clothing, and a whole range of things. So you bring all that experience into this relatively new space.
Yes, it's that fusion between health, safety, and an understanding of what we do is not necessarily known by a lot of people. They tend to look at you and go, "Oh yeah, you're the fun subject. Kids love going down there, and they'll walk out with pencil boxes and dartboard cases and coffee tables and all that sort of stuff." And yeah, okay, all those things are great, but it's more than that. It's getting them to understand that it's more than just the vocation, although the vocation to that physical making of something and understanding how to use different tools and work with materials is great. And that's the end product of what they get to see, but not necessarily understand the nuances of being able to how to work in those spaces and even how to maintain them. And the work that has to go on, particularly now. I mean, now that the litigious society has made its influence, and not only that, but obviously as incidents occur, we have to be making sure that we're keeping the kids safe, and of course that our employer is providing us with a safe work environment. And I think that's what often gets forgotten about, particularly when we're designing spaces. And you mentioned before about architects not quite getting it right, but the design process for a school is much more complex than just architects not knowing, because architects rely on consultants, and consultants, although they might have the appropriate titles, sometimes don't have the knowledge and the nuance about what it means to be in those spaces, and the working systems that are involved in it. So I've seen plans where you have a driveway coming in, and they say, right, well, at the end of this driveway, we're going to have all of the services. So that's where the bin's going to get kept. We're going to put the dust extraction system on the end of the building. I go, yep, great, that's fantastic. Have you made a ramp that goes to the back of the actual dust extraction system? And are you modifying it or telling the supplier that you want a bin system that can actually safely roll out, be picked up by a service agent, and then actually dumped into the back of the truck, dropped back down again, and then safely wheeled back up and then sealed back up into the actual... No, yep. I haven't thought about that. And I said, well, that's manual handling. Who's going to handle the bin, number one? And number two, who's going to open it up and then have to deal with the dust that has just been collected safely from all the kids? But now you've got someone in there that's going to be breathing it in, all that sort of stuff. And let alone, and you've actually now just tucked the roller door to actually get into the workshop and the storage area for all the timber and metal and everything else that we use is now around the corner. Can you not bring that back around this way? So when it comes off the truck, it's straight off the truck, straight on the shelf. Oh, no, we didn't think about that. I said, well, these are all the work systems and health and safety issues that we're not just worried about kids, we're also worried about staff and TAs. I think they get forgotten about too.
Yeah, because it's one of those things, and there's so many schools, because it's not cheap to build a school. It's not cheap to renovate a school, and quite often, unfortunately, the industrial arts, design and technology, we're often pushed to you can just fit over there.
Yeah.
And so all of a sudden we have to try and retrofit this workspace that was never designed for us. And like you said, we order in 6 metre lengths and we order full sheets of plywood. So we've actually got them in, we've got to cut them, we've got to store them in a space that actually wasn't made to allow that sort of stuff in. And you talk about, earlier that, it's the subject, kids love it, it's fun. And thankfully it's starting to change, or he's not really good at math, so we're going to send him down to you. And we're trying to say, hold on, he's got to learn math. He's got to know math.
Yep.
These kids, these young boys and girls, they're learning about space. They're learning about measurement. They're learning about volume. They're learning about weight. They're learning a new language. They're learning how to operate all these even, the hand tools. They're learning how to use all these things, and you're saying they're not smart? Come on.
And I find it the greatest that STEM and STEAM are now the biggest, big words and the taglines, and really that's where the finance is currently sitting in terms of funding and getting programs going and investment in schools. One of the things that's coming out in the literature that I'm reading through, so I'm going back through the history of technologies. So I've wound the clock back 100 years. So I've got printed texts from bound books from America. They're talking about industrial arts. Go back to industrial arts, and you read through that, and it's the same issues. This is what you do with students that are disengaged. Safety is a major part of all the workshops. This is fundamental. You need to do this. You need to make sure that you've got your housekeeping. You need to understand what projects you're and they also talk about that idea of there's a certain cognitive level that has to be applied within the trades that I think people forget about. And it's still eye-opening when you walk in, you say, yes, okay, you might have a company come in to help you out with your Cert 2 building construction, or you might be running it yourself. And, of course, one of the modules or units of competency in that is setting out, and then all of a sudden you pull out the word Pythagoras. Yeah, we're going to do our 3, 4, 5 set outs. Hey, what? You're doing Pythagoras? Yes. They need to understand that. They need to be able to do the calculations because it helps us square off a site. Oh, wow, I didn't realise it got that detail. Yes.
And how much concrete's going to fit in this form? Oh,
yes.
What do you mean? Oh, well, you got your length, you got your width, you got your depth. There's your volume.
Yep.
And all of a sudden, these kids, they're just like, whoa, hold on, I need something.
Where'd that come from? And my current school, we twisted the curriculum slightly, and our Year 9s are studying a subject we call amazing materials. So this is a semester-long assignment or unit, and what we do with them is we introduce them to all of the different areas. We go through from timber to metal to plastics to textiles and plastics. If I didn't mention plastics, I can't remember. We intentionally go through the testing processes and we talk about those different materials. So last we ended up, I ordered in some pine, some balsa, and some exotics. We cut them to the right size, and then we did a drop test on them. So this is mimicking what we actually do in the engineering general course at QCE. So, they're running upstairs, they're dropping 10 mil steel balls, they're getting out vernier calipers, they're measuring the indent. We're giving them the Benel indent test formula, and they're going through and calculating the hardness of each of those timbers. And they're all looking back at me and saying, so this is technology. It's like, this is advanced maths. Like we're only just touching on some of this stuff in Year 9 mathematics. I'm going, yeah, I know, but isn't it exciting? You're finding out how hard some of these timbers are. And when you start holding some of them up and go, okay, well, this is balsa, hardwood, softwood. Oh, that's a softwood. Okay, all right, I'll put that down on a piece of paper. Pine, hardwood or softwood? Oh, that's soft. Okay, yep, no worries. And then I think we've got ironbark. All right, what's this one? Oh, that's a eucalypt, and that's a hardwood. Okay, wonderful. Right, now let's just do a quick Google check. Have a look at balsa. Is it hardwood or a softwood? Just confirm your theories down on your piece of paper. So this is telling it's a hardwood. Yeah, funny that, isn't it? Why is that?
I love doing that. And then, you're talking about the material science of it all.
Yes, yeah. So, of course, what I've realised, I mean, we mentioned it before, we've both been teaching 20-odd years. What I've realised in this time, and something that probably falls back to me being an industrial designer, is that I valued the understanding of the material specification before I went about designing something. So I had to know, what are my sheet sizes? What are my material thicknesses? What is the hardness of those materials? What adhesives can I use? What fasteners can I use? What should I be using? Not what can I get away with, but what should I be actually using before I went through the design process. And I couldn't design successfully until I understood my materials, because I could then actually start to say, right, well, I'm designing a light. I'm now going to put this type of globe in. Okay, I understand that type of globe is going to get up to this type of temperature and therefore needs this type of circulation. That rules that plastic out, this plastic out. I want it to be held, or I want it to levitate off a metal base. How do I do that? I could use screws. That looks ugly. I could use this. That doesn't look nice. Maybe if I indent the metal and then I go and buy some rubber grommets or O-rings, I could put them on, slide them up, and that holds the plastic in place without any screws or glues or anything else. That looks nice. Wow. That was the design process. So our sort of thinking for this particular unit is we want the kids to understand these materials and what their properties are, because otherwise if we give them a piece of paper and say, design something for this person, they'll come up with a design. they won't understand what they're designing or how they specify it, or even when they get to their cutting list after they do their technical drawings, they don't know how to specify the materials because they'll go, I want a piece of timber that's this long, that high.
I want wood and metal.
Wood and metal, yeah. Or they'll start writing it down, and it's like, I don't think we can actually buy that timber, 50 mil thick. You're probably going to have to buy multiple. We're going to have to cut multiple lengths and then actually laminate them together. Oh, why is that? So, well, because the tree doesn't actually grow that big, or you get dimensional instability as the tree actually dries out, becomes close to 12% moisture content. So, we talk about those complexities of the design process, and I suppose this is where we've got to try and find that right degree, design process and gradual release, and so that's the pedagogical side of the design process, and how we apply that within schools and where we balance it out in the curriculum. Because you're trying to get kids to design things they're just not ready for. And as much as I love the divergent thinking that kids have got, I want to do this. Yeah, okay, let's get that idea back.
Yeah.
But showing them these different things and getting them to understand, how that machine works and what that machine does and how that processes that material is a huge thing. And ultimately, what we found, even just running this course for months, is that our kids coming into year 10 design are actually now much more switched on, can work through that design process without struggling with it as much.
Yeah, they're looking at that fit for purpose. They're understanding the materials correctly. From everything from what's actually available to is it the right timber? Is it the right plastic? Because you could use this particular, you could use a thermoset plastic or a thermoplastic. What's the, and they go, oh, hold on, and all of a sudden, and I remember back when we were on the when I was on the tools, these engineers would send these amazing drawings down. Yep.
Yes.
And they would put these material specifications down. And as the manufacturing side of things, as the practical engineer, because that's my trade was mechanical engineering.
Mm-hmm.
We would get these things down, and because we understood the materials, we'd have to send this stuff back. And I remember one time our whole shop floor got in trouble. But we stuck to our guns because this particular engineer goes, you've got to use this steel. This is the only steel you can use for the job. And we're going, no, it's not. You can use this. Why can't we use it? We're not using this. We kept on sending this drawing back. And they're like, what are you doing? Well, and we go, okay, so this steel that you want, we're happy to wait for the job. We can wait. The customer's not going to be happy, but we can wait. We'll do something else. What do you mean? Well, that steel is only manufactured in Germany. It's got a 6-month lead time.
Yep.
And then you've got the shipping to get it here. Oh, so what should we use? Well, if you use the local Australian-made steel, it has all but one fraction of the properties that you require, and that property that is actually missing, we go through post-treatment, and it does
the same thing. Yep.
And that's sort of what you're doing with these, with the students. It's almost like year 7 and 8. We do give them a bit of, sort of recipe projects. We give them a little bit of creativity and a little bit of design work. We talk about design thinking. But then what you're doing in year 9, like you're going, here's that practical side of things. Let's see what materials do. So that when they mature as much as a year 10 can, but they're maturing in the subject.
Yes.
They have that greater understanding of what can actually be done inside their ecosystem.
Yeah, and it's married with a tools, machinery, and safety course. So the hope is that and that they're then married with a design drawing. And I think this was the other thing that's always sort of done my head in a little bit is that when you actually look at the busyness of the technologies curriculum,
it's ridiculous.
You've got the design process, you've got freehand drawing, technical drawing, materials understanding, working processes. So not just using the machines, but actually sitting down and writing out a procedure to say, oh, I'll cut this with this particular tool, that particular piece of equipment, and then use this particular machine, and then get this type of finish, and then apply this type of finish or what have you. So there are so many things. Then there's evaluation, and then there's design briefs, and then there's product design specifications with their own attributes and understanding all the nuances of those. And then, of course, you've got psychology, literacy, and numeracy, and all these other things. So we ultimately looked at it and just went, you know what, even with our workforce planning and having the diversity of teachers that are coming into us without trade backgrounds or necessarily being industrial designers or builders or boiler makers or anything like that. So, okay, let's break it down a little bit. And we're still going to go through each of the different materials, but the tools, machinery, and safety, which goes through just, we're going to go through each individual area and you're going to use these. You're going to understand what an SOP is. You're going to understand what a safe working procedure is for that particular machine. Talk about PPE and the importance of, aprons where appropriate, wear footwear, not skylarking in a workshop.
Yeah.
And then we've got a design drawing course. So we go through freehand drawing and technical drawing and the ins and outs of, what's an isometric and why do we use that as opposed to an orthogonal or an orthographic. And then this is our CAD system. So, let's play around with it. Let's model something up and do some reverse engineering. So by the time they go through, like, even if the cohort only gets to experience one of those electives, the mix of kids coming back to us at Year 10 then starts that conversation. There'll be a student sitting there with a blank piece of paper and going, I know how to process the material, but I just need help thinking about the material. Oh, I did amazing materials last year. Let me talk to you about it. What do you need to know? Timber, metal,
And then
styles.
you've got this peer-to-peer learning and teaching and learning with the peers, and who often can do it in a way that we never could, and they can explain it to each other in a way that they understand.
Yes.
We just, I mean, I don't know about you, but it's probably the same. Sometimes we sit back in awe of this pain in the neck kid who all of a sudden is teaching his mates or her mates
Yes.
these concepts that we didn't think they grabbed,
Yep.
that they weren't listening, but all of a sudden they're teaching their mate, and you're just going, "How did this happen?" And it just brings you joy, and it's, I guess, it's part of the reason why we do teach.
Yes. Yeah. Well, it's those light bulb moments, and it's those rare occasions that you get students come back to you and go, "Hey, sir, I know I was a pain in the backside. I know I pushed your buttons, but thanks for everything that you did because now I'm doing this and I'm loving it." Or, you know what, I'm actually not in the field, but the things that you taught me and the things that you got me to think about have now made me much more of a critical consumer. That when we do these jobs for people, we're methodical and we take our time and we talk to people and we've learned how to get information out of people to make our service better for them. That's the ultimate reward. Or when you're flicking through LinkedIn and you go, that's an ex-student of mine. They're now a model maker for an American or a European car company. And you're going, wow, that was just from a quick conversation with them in the afternoon to go, where do you think you're heading? I don't know. Have you thought about being an architect or an engineer or an industrial designer or industrial design engineer or something? And it's, I never knew about that trade, or I never knew about that job, or I didn't know that I could apply those skills to that particular, trade path.
Absolutely,
okay,
yeah.
brilliant. I've set you on your way.
And I do that to so many students, and often the biggest hurdle for these kids is they want to go and do something. They know that school is just not the right environment for them to succeed at this point in time. The best place to do it is in a trade. Like especially the young men, they don't want to sit down, and they shouldn't have to sit down for 6 hours at a time. They need to be out doing something. They're full of energy. They're full of they just want to do stuff, and it's just like, go get a trade. But mum or dad say, I'll never get anywhere with just a trade. And I said, you might,
It's a starting point.
but you hate school, but you love doing stuff with your hands. Go and do something with your hands for 4 years, because the worst thing that's going to happen is you're going to earn money and you're going to learn a skill that's going to get you into the next door. And I find nowadays, societally, we're looking at trades are becoming more and more sought after. These young men and women are earning After look, they have to go through a trade. They have to do 4 years of hard work. They have to
Yeah.
learn a lot.
It's still uni, and that was one of the conversations
They're
I've
getting
always had.
paid to do it.
Yeah, it's still uni. Like your trade apprenticeship is a university for someone who's on the tools and in a vocation. And there's nothing wrong with learning those skills and getting yourself a certificate. The certificate's going to last you a lifetime.
Yeah.
Let's be frank. When they're doing Cert 2s and Cert 3s, they're actually sitting, on an Australian qualifications framework. It actually sits above the Year 12 qualification. So those skills are going to stay with them. Yeah.
Yeah, and they're leaving school with tertiary qualifications that are going to put them. Yeah, and they don't even. And it's almost like we trick them into learning.
Yes.
Yeah. Hey, do something that you love. Get out there.
And on the flip side of that too, we this semester I'm currently co-teaching one of my classes, but we've got a full complement of girls in the class. If we went by traditions, they probably would want to be something in textiles, and we've worked with these girls and engaged them in doing materials-based subject and looking at the science behind materials. And now when we ask them is, are you finding this stuff interesting? Yeah, we do. We're really keen for this. And it's like, okay, well, we're still going to go up to textiles because next material is textiles. We're going to look at stretch factor, absorption. We're going to go into the science lab. You're going to cut 50 mil squares of all of these different textiles, and you're going to burn them. And then we're going to record all of our results. And what I'm hoping out of this is that we then see those girls follow that through, and then we end up with girls in engineering, or a lot more girls in the design stream of our subjects. And in fact, I think we've been fortunate enough to take on an automotive program, which is amazing. It's a brilliant program up here in Queensland, run by Formula Schools, and we've got a couple of female students coming through that program. So they're learning about how to actually look after a car, how to service a car. That will then lead on to engineering Cert 2 in engineering pathway. So they're going to be able to come in, and then they're actually going to be able to fabricate a car, and then we go out and race it at the end of the year. It's not really a race, it's an endurance event. But that's getting them really keen. When we come back to STEAM, for example, I love the idea of STEAM and complementing technologies, but more so for that, that really not interdisciplinary, but transdisciplinary. And I know it's a time that gets sort of thrown around, and sometimes people don't quite really understand the association, but it is something that is not only just connected, so we're connecting those letters in the acronym and making sure that we see the through lines between all of them, but then we're also relating it back to industry and how those roles, jobs, knowledge, skills, all of that stuff gets put into real life jobs, and then what they'll be able to take from that and they're learning at school and then go into the workforce and go, yeah, okay, well, I did this at school. And again, it might not relate to their particular career path that they end up being in, but it's one day you will turn around and go, in that job, I remember doing this in a technologies or a STEM related subject. I can now apply that knowledge in a way that I never thought I would. And how great's that?
Absolutely. I mean, like with I speak for myself, and I know another colleague that at times I've found, and I do find that the STEM and STEAM terms quite hard to follow.
Yes.
Because as an experienced design and technologies teacher, industrial arts teacher, industrial technology teacher, someone who's taught food tech, textiles technology, all those various materials technology. It's like that's what we do every day. We look at the science materials, we use various technologies, engineering, of course, and mathematics is in everything. And so it's just like I understand why the terms were introduced. And it did bring especially the girls who wanted to get involved, traditional male subject. It's given them the opportunities to come in, and that's fantastic. But yeah, people need to, I guess, fully understand that it's transdisciplinary, not multidisciplinary. Everything ties together, because if it doesn't work.
Yeah. And
It's a tough one.
well, I, that whole thing that you just touched on about the disparity between, well, you've got the chief scientist that turns around and says science is important and we need more scientists and we want more females in science, or we want gender equity in science, a better way of probably saying, so we're not veering too much to either side. But then you get, the mathematics people then turn around and say, oh, well, maths is really important and it's essential that you do that for science. And there's those two letters in the middle that always get forgotten, or the T always gets assigned to IT because everybody's go-to is technology is ICT. Well, no, it's not. Technology is any machine, any process, any system, any tool that gets picked up that assists a human being to do whatever it is that they need to do. And I think it's a lag over from, it's really interesting how this actually relates back to health and safety, because when we go back and look at the transition period in the 80s and 90s from industrial arts, industrial technologies, even a little bit of a layover from the manual arts, because it was all fused together, those particular terms. The political shift that we had during the 80s and 90s, even the original falling little rocks that caused the avalanche of us going towards a national curriculum, really did a disservice to the continuity of industrial arts into technologies and design and technologies. It was very much misunderstood, and fused in that area, of course, is that industrial arts was, before TAFEs, was our vocational training for our trades. So we've sort of maintained the vocational trade vet association, but we haven't quite really promoted the idea that the subject is centered around solving problems, aka design, using technologies. And I think the way in which the Australian curriculum was sort of rolled out, and this is what I'm trying to find the solution to this in my research for my thesis, is pinpointing where that actually happened. And it's very difficult because politics had a lot to do with it. And even the way in which the curriculum was first scoped and how it was written and how it was rolled out and why there was suddenly a need to have design in technologies. And then, of course, how we modelled our curriculum off the UK design and technologies area. And then, of course, the transition in terms of teaching staff. So, of course, once we shut down technical high schools, and sort of roll those staff members into secondary colleges, but was the PD and was the communication and the philosophy or the pedagogical approach of technologies really refined? And that's where I think we've sort of stumbled quite a lot as a subject, and that sort of then leads into the problem of the misunderstanding of the T and E in STEM and how we could all work together and just say, okay, let's get rid of the traditional subject disciplines, forget that for the moment, and then just go, you know what, hey, arts, come in here too. Because if we actually make it STEAM, or whatever acronym you want to come up with, doesn't really matter, but as long as we're then working together to actually promote each other and go, well, you know what, science is knowledge. So we translate the original word from Latin, science is knowledge. Technical or techniques is the doing part. So, the solving of, I'm going to argue this because I'm biased, it's like, man didn't sit there and go, I'm going to come up with a unique marking system or measuring system first. They picked up a rock, threw it, didn't work, went through the iteration process. Okay, I'm going to now go to a spear, throw that, no, it didn't work. Okay, I'm going to shorten it, I'm going to lengthen it, I'm going to put a tip on it. Then they started coming up with tools, and then it was, okay, well, now that we know how to do all this stuff, we need to document it. Well, we need knowledge and science to do that. Right. We need a literacy program, and then we also need numeracy to be able to communicate this from one generation to the next. Tech first.
Whoa.
Science second. But through just the human development, we've gone, okay, well, now we've got classics, so it must be science, maths, English, music, others, PE, and now we'll include technologies. So,
and it's almost, to a certain extent, it's been flipped. The only crass term I can think of is ass backwards now.
yes.
And look, for whatever reason, mostly political and why it's been done. But like you were saying, we have the science of that knowledge and those theories of trying stuff out. But then the engineering is actually putting those theories into practice. It's actually solving. Yeah, I think this. We're going to see if it actually works.
Yep.
And like you said, started with the rock, started with the spear. Let's roll this down the hill. Hold on, that's got sharp edges. That's not going to work.
Yep.
And all of a sudden we've got this. So it's like, okay, well, we're drawing in the mud. Hold on, if we get a rock, we can draw on another rock, and then if we get, and so on and so forth. And now we're 3D printing, and we're.
Yep. And don't get me wrong. I think at the end of the day, we're all integral. We need balance and harmony between all of those things. And you're right. It would be nice if everybody on the playing field would actually just go, you know what, I've got to hand this ball to my technology counterparts because they're going to be able to run with this, and we're going to recognise their key existence in this game of progressing society or lifting our next generation to make sure that they don't make our mistakes and look after the globe and all that sort of stuff. And I mentioned before that it actually relates back to technologies in a way. In that same political process that we went from the 70s through to the noughties, it was actually in the 70s that we rolled over to the Rubin's model of work health safety. So that was Lord Rubin in the UK, who turned around and said, right, let's actually go to this model where industry can actually look after their own selves. We don't have to legislate everything. And we then adopted that in the late 70s. It took us 20 years to harmonise it, to go from individual states with their own workplace relations to then a national harmonised Work Health Safety Act of 2011. But in that transition, back in 1973, we actually had an Australian standard for what our workshops should look like.
Yeah.
And that got revised in the 80s, and it actually is still current, although it's labelled as withdrawn. But that Australian standard was based off a British standard. It still exists and is actually updated, and it's got some really great resources in it if you jump onto the Australian Standards website and download it. And in when was it? 2006, they made it withdrawn, but it doesn't actually take it out of service. We can still actually use it, still reference it. But that actually gives you all of the specifications. Well, not all, as much as we knew back then, but as much as we can relate it to the Australian standards that existed then. But that gives you a much better idea of the safety requirements and the things that you should be thinking about in your workshops and laboratories for technologies. But it was specifically written for workshops. I'd love to see that revised, but it has to get each state's education department, the Australian Health and Safety Institute. There was a couple of other people who were involved in it. But if we can get all those people back around the table and go, hey, yeah, this was important. Yeah, we need to actually specify this again. Then we can get the relook at setting up a standard for what a workshop, kitchen, lab, all that sort of stuff could look like for technologies.
Well, it looks like once you graduate your PhD, you've already got your next task set up. So
keep me. Well, we're a year in. I'm just at my confirmation, so that's where they actually look at your question and go, yes, that's something that you can study. I'm pretty confident they're going to do that, because I can tell you now, even just from the general conversations that you watch on the ITD forum up here in Queensland, and then the conversations I have across New South Wales, and of course all the other things that happen in the media. In and around student safety and workplace safety. There is lots to discuss and lots to understand. And even just the sheer fact that if we go back to 1970s, there was more information out then about what a high quality workshop environment would look like than what we have now. And it's not necessarily that we know less, we know more. We know more about toxic fumes from welding, we know more about hazardous dusts from timbers, particularly Australian timbers that are some of the most deadliest. Not that we have a lot of those timbers in most of the timbers that we can buy commercially. That's the really old eucalypts that we used to cut down and do things with. What else? Lighting standards, fumes, chemical management, all that sort of stuff. We know more because we've got more codes of practice, we've got more compliance guides, we've got more information out there about how to manage all of these things and risk assess them in environments. But what we don't have is a really clear guide that says, this is what a good space looks like, and this is how much space you actually need to be able to have 24 year 7s, 24 year 9 or year 10s, or however many kids that you want in your senior subjects. And that's what we really need. And that's what I'm hoping to answer and provide people with at least some recommendations to solve those safety issues.
Yeah, and it definitely sounds like it's funny, and I think it's I look forward to seeing and hearing how you the things you learn and how you actually start to implement them eventually, or how it gets implemented, and what changes need to be made. But again, I think it comes back to as well one of those. It's that shift that we were talking about of what's now considered important in the political landscape. What's going to do this? What's going to do that? What do we? I think Australia is such an amazing country. We have amazing researchers who don't get the credit that they deserve. We have amazing designers who, engineers who unfortunately have to leave our soil.
Yes,
the value that they have and the impact that they'll have in society and like global society, they have to go overseas, and then we lose that opportunity.
Yep. I think that was the biggest. I don't know how factual this is or something that I've picked up over time. But I think that was the biggest thing that someone like Germany actually learned was that they're not an area or a part of the world that has a huge resource base. So unlike us, where we've got a nice big backyard that's full of precious metals that we can then dig up and sell off, they had to come up with something that allowed them to become an economic part of the world. So it was their intellect.
Yeah.
Even if we ignore the war periods, and you look at the Bauhaus, look at what came out of that, look at who came out of that, where they ended up. They went over across to America post-war. I think we need to do something similar in that we produce talent after talent after talent, but where's the money at? And as you identified, the money's overseas. So, I know a lot of the graduates that I went through industrial design with have no longer work in Australia. They're over in Europe or Japan or China now, or over in America. It is sad to see industry leaving us. I mean, if we just refer back to our car industry.
Yeah, absolutely.
We had, multiple car manufacturers here in Australia who were producing great products, but the viability, I think at the time, when they were selling cars, we didn't have the population that we've got now, but the viability of their products, I think, ran its course because they just couldn't get enough ingenuity and enough throughput to make it viable to put simple things in like heated seats or, big screen TVs in the dashboard and all that sort of stuff. And then when you've got European models that can churn out lots more and develop more or earn more money from their product, then, that makes it more economically viable. But it's looking after, and I think you're right, looking after the intellectual property and the people who are here and nurturing them and saying, well, yes, you've got a fantastic product, so let's do what we can to make sure that the investment comes into the country, gets that idea produced, or that we can utilize you as a resource to say, right, well, you're doing these fantastic things, you're solving all of these problems, and, why can't we have a product that comes on the packaging, designed in Brisbane or designed in Sydney or designed in Melbourne? And it might be manufactured overseas, but it's the design thinking and the aesthetic and the ingenuity of the product that actually makes a difference.
Yeah, and the intellect.
We'll get there when we can make sure that design technology is centre to everything that we're doing.
Absolutely, absolutely. Now, I reckon we could probably speak for another, probably another hour, at least, without running out of breath. But again, yeah, we could go on, and there's so much stuff that we didn't even really get to touch on with some of the stuff that you're doing.
Part two.
Yeah, absolutely. We'll do part two in the new year when we both had a good rest over our Christmas break. But I want to thank you for your time. I want to thank you for the knowledge and for the passion that you're putting into these students to give them every opportunity that they can have to get to a level of success. I mean, geographically, where you are, where the draw of your school, you know, it's not necessarily the most affluent area, but you're teaching these kids who are going to have, and you're going to give them the spark to go on to do great things. So,
well, I'd like to say I've got a great team behind me that helps me out with that. Being the head of department, you don't tend to get as much time in the classroom, and of course, focusing on the operational cogs within the school, you don't necessarily have the time to put the teaching practice in that you would have once as a general classroom teacher. So I've got a fantastic team behind me who do put in the effort, and I put them through their paces. But when I say that, I push them to be better, and they put up with a lot, particularly with me. What I inspire in them, and what I hope I inspire in them, is the ability to take on new challenges and learn new things. So we do a lot of training, and we try to find the time to give them the opportunity to learn new things. I'm sure that you've probably experienced in the last 10 years, we get a lot of staff that come in, and it's, have you experienced using CAD? No, never used it before in my life. Okay, right, well, we need some PD on that. Or, that's a laser cutter. Are you familiar with Illustrator and how to export it out to that? No idea. Okay, right, well, let's develop you with that and then help that out, because that's ultimately going to increase your capacity to teach. And then, of course, you value the kids, and you'll be able to get your engagement out of kids because they know what you're talking about.
Yeah, exactly. And we do it for the students that we interact with. And it's a vocation. It's a privilege that we all have. And I tell you what, we need some more technology teachers.
Yes.
So and that's what to be able to show them and to be able to share our wisdom, our experience, our knowledge, and also our joy of what it can be. Now, like teaching stressful, but if we can share that, then we can get some teachers who, last longer than 3 to 5 years, that
Yes.
they are able to stay in it, and hopefully we can do something about this curriculum as well. But
Keep it simple, and then, of course, try to integrate it as much as you can. And I think helping schools and leadership understand the nuances of the subject too goes a long way.
Importance of it. Getting
them to see the value of these programs, and sometimes not even just the curriculum, but the sideline things that have to happen. And I'll probably put my health and safety hat back on again and go, look after the rooms and the equipment and provide the time to do the training, because it is timely. My current team gave up a one Saturday to be able to walk into the workshop and actually get a hold of me for 9 o'clock until 4 o'clock in the afternoon, to basically to say, we don't want it in piecemeal half an hour hits. We want to do it. We want to stumble. We want to fall, because if we know where the stumbling and falling parts are and the difficulties are using some of these tools and processes, then we can predict that in the kids, or we can say, yeah, I had trouble with that too. And the lights in the eyes of kids when you say, oh, you've done this project. Yeah, we did it the other weekend with, 3 of us all came in, or 4 of us all came in, and we stumbled with that. And yeah, I didn't cut it straight either. They're rotten things, those coping saws, aren't they? Yeah, okay, oh, good, okay. They're excited, and it's like, oh, you had trouble. Okay, well, if you had trouble, I'm allowed to have trouble. And it's like, yes, we want you, as long as if you can show that you've had trouble cutting that, but you sit down with your evaluation and go, I had trouble cutting it straight because I couldn't stay in line because this went over that way and that went over. But this is what I'm going to do to actually correct that, and I'm going to turn this design flaw into a design feature.
Yep. Yep.
There's your 5 marks out of 5 marks because you've just learned how to actually adapt as a design student.
Absolutely. Absolutely. Yeah. And it's all that.
But
It's giving them a safe space to fail. And by failure, we can only learn by failure.
that's right. Yep, and you'll learn so much faster by actually getting it wrong 20 times than getting it right once.
And coping saws do suck. So, hey,
It's always interesting when you walk in, you see someone with a tendon saw, and they're trying to make a cut in a piece of timber down that way. You know, no, let's stop that, and we'll do it this way.
we should write a book of it'd be something to do, that's for sure. But Andrew, I'm just going to one last question
Sure.
before we go. Actually, yeah, it's my second last question because the last one will be the last one. But this one is: it wouldn't be the Tattoo Teacher podcast without asking you, Andrew, do you have any tattoos?
No.
No.
Got a funny story though. I have got a funny story. When I first met my wife, she said, "I want a tattoo," and I said, "Okay, I want a motorbike." And she said, "Well, you're not getting a motorbike." I said, "Well, then you're not getting a tattoo." We have held that. We have held that pact for 25 years. We've been married 20, but we've been together for 25. So we've held that pact for the last 25 years. I have not been able to get a motorbike. She hasn't been able to get a tattoo.
Hey, all sweet and love, isn't it? And my last question is: if people want to get in contact with you, they want to find out more about, I guess, what you do in the work health and safety space.
Yep.
We obviously we have the personal professional connection. We speak very often on LinkedIn. But what are the best ways to find you? And I'll put all this in the show notes as well.
I'll do some self-speaking here. So there's two. I won't give out my education email and all that sort of stuff. But if you go and do a Google search for a website called Andacod, ANDACOD, it's sort of named after myself. It's a stupid name I had to come up with because I'm a sole trader and I didn't want to come up with something else. So it just literally stands for Andrew Nicholls Design Associates Compendium of Design. It has been a long-term project. I'm probably taking influence from someone like Eddie Wu here, the maths guru, to basically say, if you're going to do something, just keep doing it. And if you make mistakes, as we were just talking about, don't worry about it, just keep doing it. So this has been a long-term project where I've just kept chipping away at stuff. And as I produce things, I put things up, and even the books that I've collected over my teaching career, I've got like a little reference point for those, and you can follow links, or I've got the ISBN numbers and all that sort of stuff up there for that. So that's a little website that I am have developed to help people out with design. It's a bit rough at the moment, just simply because I had to transfer from one web application to a different one. I had some problems with the programs on one platform. I had to tear it all down and rebuild it all again. So that's andacod.com.au. Looks like Anaconda, but nothing to do with Anaconda. It's Andacod. And if you're more interested in the health and safety side of things, and particularly if you're in non-government school, I don't tend to deal with government schools because the department's got their own resources and people to help you with all that sort of stuff. That's just andrewnicholsdesign.com. Any of those websites, you send me an email on those, or you can search Andrew Nicholls on LinkedIn and you'll find probably 20 million of us. Just look for my greying hair and you'll find me somewhere.
Brilliant. Well, I'll put all those I'll put those links in the show notes as well.
Sure. Thank you.
Andrew, again, I want to thank you for your time. I want to thank you for all that you're doing in the design and technology area, especially up here in Queensland.
Yeah. Anything that helps somebody, or even just a new person to the trade or to teaching, that can take something from us and run with it, develop it, engage some more kids somewhere that does something for technologies and helps kids out to get where they need to go. Brilliant.
Absolutely. And I'll also put the data website in as well.
Oh, yes. Yeah. Yep. And if people are interested in watching this data, I'm doing 2 PDs for them in the coming weeks. Not that, obviously a glutton for punishment, but we've got one on technical drawing and another one on health and safety and workshops to do it from a manageable point of view.
Brilliant. Well, Andrew, thanks again for your time. Enjoy the rest of your evening. Enjoy the rest of Term 4. Hope it goes quickly and smoothly.
And thank you, you too. Thanks very much.
Cheers.
Thank you so much for listening to the Tattoo Teacher podcast. I hope you enjoyed the conversation and found it insightful. If you like what you heard, it would mean so much to me if you could either like, follow and subscribe to whatever platform you are listening on. The music was by DJ Fruit Salad. Thanks again for listening. Stay cool. Be blessed.